Okay, so different types of intermolecular forces or van der Waals forces are: number A, dispersion force. Dispersion forces. These are also known as London forces, London dispersion forces. Uh, Next, it is dipole forces. Third type is dipole induced dipole forces. And finally, hydrogen bond. So these are the types of intermolecular forces or van der Waals forces that occurs. And as I already said, more will be the intermolecular forces than the physical state of the substance, physical state of the matter will be towards solid or towards liquid. So, what is London dispersion forces or simply dispersion forces? Suppose here we have a molecule or say an atom. There is a nucleus, and this is distribution of electron, and say this is another atom, and this is the distribution of electron. Now, as you can see, the distribution is symmetrical. Here also, it is here also symmetrical. But what may happen is that as the electrons are moving for a moment of time, for a instant of time, the distribution may become unsymmetrical. Suppose it is like this here. Suppose it became like this, and say here also the distribution of electron becomes like this. So here, since there is more electron, this portion will have slight negative charge. Here there will be positive charge. So there will be now a sort of attraction which is called dispersion forces. And this arrangement or this distortion happens only for very small period of time. The very next moment it again comes back to this form. Again it can become like this. Again it can become like this. So in this way, as the electrons are moving for a certain period of time, the distribution may be unsymmetrical, and when it is unsymmetrical, then there is a force, internuclear force acting, that is called dispersion forces. Like here I have shown the distribution of electron more on this side. It can also be on the other side, like this also it can result with the nucleus, and say the distribution is more on this side. This is another atom. The distribution is so here, now there will also be intermolecular forces. So this arrangement can change to this for a very small period of time, then there will be an intermolecular force known as London dispersion forces. Then again it can come back to this, and then again it can come back to this, and again there will be intermolecular forces. So these are called London dispersion forces, and this force is not so strong, but it is there. Okay, next is we'll discuss about dipole forces. To understand dipole forces, let us consider HCl molecule. HCl molecule. Now, HCl molecule, we know there is a covalent bond, and chlorine is more electronegative than H. So, HCl molecule will be like this. There will be more electron density surrounding chlorine, so it will be since chlorine is more electronegative, so there is more electron density over chlorine and less over hydrogen. And as a result, this side will have a slight negative charge, this one will have slight positive charge. So this is a molecule of HCl, and another molecule of HCl will also be like this. Delta plus here, delta minus here. Electron density more over chlorine and chlorine side, less over hydrogen side. So this is a dipole. This is a dipole. Two poles are there: one positive pole, one negative pole. And this is also a dipole: one positive pole, negative pole. So now there is a force of attraction. There is a force of attraction between this molecule and this molecule, and this is called dipole forces. Now, if we are asked to compare the strength of the force here and here, this force, dipole forces, are much stronger than dispersion forces. Now, coming to the case of dipole-induced dipole forces. So, what is dipole-induced dipole forces? To illustrate, let us consider this example. Okay, suppose we have in a system HCl molecule and chlorine molecule. Now, HCl molecule, because of electronegativity difference, it is a dipole, one end plus, one end minus. But chlorine, because both the atoms are same, it is not a dipole. It is, you can see the distribution of electron. It is symmetrical. It is symmetrical all over. It is same. So now what will happen is that this dipole, because it is very near to it, it will induce polarity over here. This dipole will induce polarity on here, and after that this one will become like this. This one will become like this, and there is more electron density here. There is more electron density here, less electron here. So here there will be delta minus, here there will be delta plus. So now between this and this, there will be intermolecular force. Here there was no intermolecular force, but after polarity is induced on it, there will be between this and this a force of attraction. There will be intermolecular force, which is called dipole-induced dipole forces. Now this force, you know, it will be weaker than dipole-dipole forces, but it will be stronger than London dispersion forces. Okay, coming to the last type of intermolecular force, that is hydrogen bond, which we have already studied in the previous chapter, chemical bonding. So hydrogen bond is actually a type of intermolecular forces or van der Waals forces. So what is hydrogen bond? Hydrogen bond is if hydrogen is attached to a highly electronegative element, if hydrogen is attached to a highly electronegative element, suppose Z is a highly electronegative element, then so this is another molecule, this is another molecule, this is another molecule, and so on. So because of Z being very small in size, because of Z highly electronegative, so over Z there will be delta minus, over H there will be delta plus, delta plus, delta minus, delta plus, and delta minus, delta plus, and delta minus. So actually there will be a force of attraction between this molecule and this molecule, because here it is delta minus, here is delta plus, and that force of attraction, that intermolecular force is called hydrogen bond. That we show it by this broken line. So this is hydrogen bond, this is hydrogen bond. So because of this hydrogen bond, the molecule will become slightly associated. There are many phenomena which can be explained by this hydrogen bond. So these are some of the types of intermolecular forces, and as I say, another factor which determines whether a substance will be existing in solid state, liquid state, or gaseous state, it is thermal energy. So another factor is thermal energy. Thermal energy is basically the movement of particles, the movement of atoms, or the movement of molecules present in the substance. More is the movement of molecules or particles in a matter, more will be the thermal energy. So we can easily say that from solid to liquid to gas, there is increase in the thermal energy. Thermal energy of gas is more than liquid, liquid it is more than solid. Increase in thermal energy. And we can also say here that intermolecular forces will be more for liquid than for gas, more for solid than liquid. So in this direction there is increase in the thermal energy, in this direction there is increase in the intermolecular forces. So it is the resultant of we can say intermolecular forces and thermal energy which will determine ultimately whether matter under a given condition of temperature and pressure will exist in solid, liquid, or gas. So this much for now. Okay, in our next class we will be straight away starting with the gaseous state. Till then, good night.